Hello everyone. So I'm going to take you through the workshop presentation and the flow that we have planned. So person identification via multimodal interface with a combination of image and speech data. And I'm going to present with the director of Salesforce, Joy Mustafi. And I'll talk about a little bit about myself. So as Oksana was saying, I'm currently working as a data and cloud platform engineer in West Pharmaceuticals. And these are my associations. Like I have been working with Microsoft before and have worked as a research intern in Intel, and I'm a part of VIT University. So these are my interests. My interest mainly lies with the unstructured data, particularly to computer vision, to text analytics, as well as audio analytics. So now coming to the question that why do we need a multimodal system in the first place? Now, I guess some of you have already heard this in news that Amazon Echo ordered like doll houses after hearing TV presenters talking. So it's like the Amazon Echo device, it was not able to recognize the difference between a recorded or a television broadcasted voice and the actual real-time voice. So this is an example where your unimodal system that is just based on speech is not a robust system and was not successfully able to identify the actual the problem that it was trying to solve. So in such cases, unimodal systems are not sufficient enough to combine together and form a robust system. So in such cases, we do need a multimodal system. Now, if you take example of a multimodal system, your multimodal system is something similar to how a human being actually performs. Humans never relies on just one modality to take decision. It is always a fusion of multiple modalities depending upon the speech, the vision, the touch, anything related to sound or aroma, and a combined uh, modality, I mean combined fusion of these modalities actually works for human. And based on these like like different types of modalities, a human being takes a decision. So why won't it work for a particular machine or a system which can rely on multiple modalities? So coming to the classification of multimodal systems, there are different types of representations and there are different ways by which a multimodal system might perform. So there can be individual modalities combining which you can come up with a representation. So this is mostly called as a joint representation, or there can be something like a coordinated representation. So if you have individual modalities based on individual representation, it can be combined and be formed as a joint or a coordinated representation. Now there are different fusion approaches as well in a multimodal system. So by fusion approaches, we mean that if there are different types of modalities, how do we actually combine and come to the final decisions? So there is an approach called model agnostic approach in which you have different types of model. So you train the different modalities together, and based on the combined modality, you then apply a classifier to come up with your conclusion. Such a system is called an early fusion system. But the use case that we'll be demonstrating in the ODSC workshop will be related to the late fusion technique. So in late fusion technique, you have the individual modalities, you pass it through individual classifiers, and after that, you combine the result and come up with the classified prediction. So this is mostly the fusion technique that we are going to present in the ODSC workshop. And there are other things as well, like which are model-based approaches, depending upon the algorithms or the kernel-based methods that will be used. But mostly our focus for the workshop will be related to late fusion technique. Now, as I said, for this workshop, we'll be targeting with speech data as well as image data. So in image data, it will target on subject identification using the face recognition techniques. So I'm going to talk about a little bit on this, although in the workshop we are going to focus mainly on the implementation, but these kind of knowledge will be really good to have, particularly for understanding the entire flow of the workshop. Now, one confusion, what I have seen over the years people generally have related to face recognition versus face verification. So what is the exact difference? So in face verification, you try to find out whether the person is an authorized person or not. So you basically do a one-to-one matching or mapping. But in face recognition, from let's say an image in which you have multiple faces, you try to find who is that particular person. So in such a case, you try to do a 1 to k matching. So in such cases, if you have k number of users already enrolled to your system, you try to find out which is that particular user from the enrolled users. And one particular algorithm that we'll be using in our workshop is one-shot learning. This one-shot learning, I found it to be very powerful because it tries to come to the prediction or the final conclusion based on just one single image and not from the entire set of training things. So it's like you have a pre-trained network, and from there you try to take one instance of the image and you try to recognize from that. So one-shot learning works in some with something called learning similarity function. So it's like you try to input two images and you try to find the degree of difference between the images. So this goes through something called a Siamese network. So in Siamese network, based on each individual image, it tries to create a vector embedding based on the Euclidean distances between the images. So you will get a vector embedding for all these images as an input, and based on that, as I said, you will be using the Euclidean distance and try to find the uh, distance or the difference between each input image. And based on that, you try to compare whether the input image is mapping with the image that is existing in your system. And again, there is something called triplet loss function, which is very much important in one-shot learning and Siamese network, because along with your positive image, you should always try to compare with your negative image as well. So based on the degree of differences between the positive outcome and negative outcome, you come to the final conclusion whether the known person is found or not. So your final face verification depends on this. So this was about a single modality, but as I said, we'll be combining both the modalities using late fusion. So the second modality is about subject recognition using audio. So in such a cases, in such problems, the first uh, approach that we take is finding a wake on word, because speaker identification, which is like independent of any key phrase, is extremely difficult to train. So an easier alternative is to work on a trigger word or a wake on word that will be used to uh, do the speaker recognition work. So based on that, once we have that, we usually follow certain algorithms like 1D convolution or long short-term memory or LSTM, or a gated recurrent unit or GRU, which is typically used to come up with the final analysis for speaker identification. So similar to your image identification from a speech input, you try to come up with an audio embedding, and that audio embedding is passed to a CNN layer, and finally you come up with the classifier. So after that, once we have the final results of modality 1, which is related to computer vision, and modality 2, which is related to the speech analytics, we try to use the late fusion technique to combine both this individual modality results and come up with the solution which is much better than the actual or the individual results. So this is how the system actually looks like on a very high level. You have modality 1 and the classifier, you have modality 2 and the classifier, and finally you apply it through the prediction layer to come up with your solution. Now you might be wondering, in what are the use cases where these kind of systems are actually useful? So as I said, or initially as I took the example of Amazon Echo, where just based on speech data, it was not able to predict properly. So in such cases, there might be a system which depends on both your input image as well as the input speech for identifying a person. Let's take example of a low light condition where your face is not properly visible, but your voice quality is good enough. So based on these two parameters, you can come up with a much better final output result that you're expecting. And alternatively, let's take an example of a system which is trying to predict or which is trying to do the person identification. So for the image quality is good in such a case in a proper light condition, but there is lot of background noises. So only a speech system with too much of background noises might not be sufficient enough to come up with the final result. So in such a case, you try to combine both things using this late fusion technique. It can be like easily done, and the final result will be much easier. So I'm gonna quickly show you how we are going to demonstrate or the how we are going to conduct the workshop session. So the workshop session will be in Google Colabs, and it is similar to a Jupyter Notebook interface from which we are going to demonstrate the entire code and the entire flow. And based on some of the data that we have given, you can try to do the actual analysis and see how a multimodal system is much better than any of the unimodal system.